So before we get into content, just a few things I want to make sure everybody's on the same page of. The project, all the documents are linked. As soon as I got home on Friday, they pushed to the website so you have access to all the documents. Important right now is your team formation form. Once you know who your team members will be and you have a GitHub created and choose a team name, submit this form and just let me know. Team name, email of all your team members, 4 or 5 team members. So if you have 5, of course, fill out the 5th one. And then your GitHub URL. It does have to be a public URL. If you have a good reason to have a private URL, message me. We can start a conversation and we can see if it's a legitimate reason or not. The deadline for that is going to be Friday, the same as Homework 1 deadline, which is on the schedule now. Team formation due. That was an implicit deadline, but I'm making it explicit just to make sure everybody's aware of that. Because week 5 meetings are going to start. You're free to schedule your meetings whenever you'd like. Work with your team, find a time that meets, means of meeting that's suitable for your team, where to meet, etc. And then for every meeting, every team member should be filling out this team meeting form. This includes what you've done since the last meeting. For the first meeting, if that's nothing, that's fine. Just put NA or whatever, what you've accomplished since the last meeting. If you actually did accomplish something before the meeting, make sure you put that in there. Maybe you're the one who created the GitHub repo and added everybody as collaborators. Get that in there. Make sure I know that that you've been contributing, that you've been doing something on the project. And then what you're going to accomplish before the next meeting. At a minimum, your meeting should consist of talking about what everybody is going to do before the next meeting. What's everybody's task? Make sure everybody knows what they're supposed to do, and then they're going to report. This is the task that I have before the next meeting. And for these first few meetings, it's fine if that task is study how Flask works, study how Django works, etc. They can be research tasks. I don't expect you to start cranking out code right from week 5, because we got a lot of stuff to learn first before you can do that. Although the project is somewhat disjoint from, that sounds bad when I word it like that, but somewhat disjoint from the lecture content. Where lecture content, I'm showing you how to get things done starting with a TCP socket. And for the project, you're allowed to use libraries. So you can start this long before we get to the lecture content. Like, for example, WebSockets. You can pull in a WebSocket library, read some documentation, and get that working before you really understand the fundamentals of how WebSockets work. There's nothing stopping you from doing that and starting the project quite early. But for now, if these are research tasks, that's fine. And then rate each of your teammates just on a loose 0 to 10 scale on each teammate, and then including yourself, and comments, especially if you give them a low score. I know I said this Friday, but I want to repeat it just to make sure everybody hears all this. If you give them a low score especially, please add comments. If you give someone a low score with no comments, I'm likely to ignore that, because I don't know, I have no context for that low score. I don't know if you're just venting. I don't know if you had an argument at a party or something, and it's completely unrelated to your I have no idea. If you don't leave comments, I have no idea. If you leave a comment saying they were supposed to get this done before this meeting and they didn't get it done, okay, that's crystal clear what you're mad about. Then I can look at their form. Well, did they submit that they were supposed to do that task? If they didn't even report that they were supposed to do that task, there's something I can work with there when I make an individual grade adjustments at the end of the semester. But if you put give someone zeros all the time and don't give any comments, you give me none to work with there. And then especially if you give no comments and then complain at the end of the semester and say, well, I did all the work for the project. Yeah, let me know that. Let me know that through the meeting forms. And overall comments, just if you have anything else to say after all of that. So starting next week you'll have your first meeting, you'll fill out this form for the first time. And never hesitate to fill out this form more than the required number of times. Of course, once per week from week 5 onward. But if you have something to say, something you want me to know related to the distribution of effort across the group, just fill it out more times. Fill it out every time you have an interaction with the team. I don't care. You can fill it out more than once per week. If you have something to say, let me know through this form. This is my source of information for the individual grade adjustment. So if you're the one doing all the work, let me know. Give me all the information you can give me to help me make some decisions at the end of the semester. Project requirements I went through. Report template, we'll talk about that later. In presentation, we'll talk about that later. But your task right now is to form the team. Form your team. If you haven't already, if you have already, submit this form with your GitHub and team name and team members, and then start scheduling your first meeting next week with your team. Okay. Any questions on what's going on with the project? Yes.
Is there any way to know how we should be pacing the project? Like how much work we should be getting done a week?
I don't, only loose guidelines. What has taken up all my code helper? I only have loose guidelines. What the hell is code helper? But in general, if you want a general guidance of where you should be each week, try to follow along with the lecture content. So when I cover image uploads in lecture next week, add that to your site as much as you can with maybe some delay. Maybe after the homework where you implement something, then implement it to your project shortly after. So if you're following along the lecture content with your project, I'd say that's the best way to keep on track. But really, the real answer is whatever works best for your team. Just please, please don't wait till the last week to do everything. That's the absolutely worst way. But if you're following along with lecture content and maybe lagging the homeworks by a week or two, that'd probably be great. I don't know, my laptop, I don't know if anyone can hear it, but it's burning up. It's spinning up on all my cores, and I don't know what code helper renderer is. I don't really have much open is the problem. Might be Docker. It might be good. I just don't want to run out of battery before lecture or fumble around with my cord in the middle of lecture. It's my main concern. Code helper. What the hell could... Oh, I have IntelliJ open. Duh. IntelliJ always takes all the resources. It's obviously going to be IntelliJ. All right. So the next announcement before we get into some content. Homework 2 is out. I posted this last night or early this morning, depending on how you look at it. Homework 2. Just want to quickly go over this. This is the content we're going to talk about over the next 3 weeks. We're done with Homework 1 content, and we're starting Dynamic Site, the Homework 2 content for the next 3 weeks. So let's take a look at what we're going to have to do. The big thing here is image uploads. Your users are going to be able to upload images to your page. That is the big task. That's the one we're building up to here. To build up to that, first we're going to talk about query strings and HTML templates. This is where somebody can request, instead of just saying, give me this page, and then you serve up content based on what they've requested. You just, instead of just sending them an HTML file, now we're going to have them request more dynamic content. They can request specific content, in this case, any number of images from the sample website from Homework 1, and we're going to serve them a page containing those images and only those images. So we have to dynamically generate our HTML on the server before sending the response back to them, to send a response with just the content they requested. So we're not just going to our HTML file, loading it and sending it. Now we're generating the HTML dynamically, and doing that through query strings. Then adding our first form. We're going to have a text form, which takes 2 inputs. They're up to you for a lot of this and most of the homeworks. You're allowed to change the samples that I give. If you want to customize it, if you want to have a site in mind that you want to build throughout these homeworks, feel free. But a form that takes 2 inputs, for my example, name and comment. So feel free to just use name and comment and have a chat room app. Name and comment, or just any chat. I guess we don't call them chat rooms anymore. Name and comment, and then that content that the user submits shows up on your page. Fairly straightforward. It doesn't have to be dynamic. It doesn't have to be live at this point, so it can require a refresh to be able to see that content. That's fine until we get to WebSockets on Homework 3. But there should be a form that works, that you're able to host content that users have submitted to you. Since you are hosting user-submitted content, IntelliJ just die. We do have security concerns. since we're allowing users to send anything to us and we're going to host that to all other users, we have to be concerned about what that content is. So we're going to start really talking about security during this module, during this homework. Why are you not? Sorry about this. Seriously, just die. Oh my God. I'm sure. I told you to. All right, so the biggest thing here, and we'll talk about it, is HTML injection, which allows users to inject JavaScript onto your site, which allows them to run their JavaScript on all of your users' computers, which is, of course, a very bad thing. So we're going to talk about how to prevent that. Luckily, the prevention is pretty easy. We're going to escape our HTML, and we'll talk about what that means if you haven't come across that yet. And then the big one, image uploads. Similar to the previous objective, objective 2, we have a form that takes 2 inputs, except now one of them is a file, which is going to be an image. And we have to be able to handle those image uploads, which is where things get really tricky. And there's a warning, I have it at the top of the homework, I'll say it right now. There's a significant step up in difficulty from homework 1 to this one, especially when you get to this part right here. The way you're parsing the requests that contain images is a big jump up. I'd say it's the first real tough technical challenge of this course. It's the first thing where you're really going to sit down, design, think through things, debug, go through your debug process. Not to say that you haven't already, but that's going to be definitely a step up from what you had to do in homework 1 and even previously on this homework. And then being able to handle large image uploads. Your form should be able to handle images of arbitrary size. Now we'll be realistic. We're not going to send you a terabyte image during testing, but we're going to make sure the image is large enough to overflow your buffer. So when you have requests that are this large, your TCP socket is not going to read all of the content of that request in one go. You're not going to be able to, say, retrieve the request, however you're doing to read bytes off of the stream. You're not going to get the whole request in one go. You're going to have to call that multiple times. This is what we call buffering and overflowing your buffer. So the image is going to be large enough that you can't read it in one go. You're going to have to read multiple times, decide how many times to read, etc. And we'll talk all about that, of course, but making sure you can handle very large images. And then finally, cross-site request forgery tokens. This is adding a random piece of information to each one of your forms on each page load, and then verifying that that token is seen on your server to make sure that somebody's not trying to attack your site. That's too broad. Somebody's still going to attack your site with these. But making sure that somebody's not attacking your site from another server. Making sure that they had to actually load up your HTML from your server in order to make a form submission. If we don't check that, if we allow people to submit from other sites, it makes it a lot easier for them, for people to attack our site. If they have, say they are able to get JavaScript injected into some other site that we have nothing to do with, and that JavaScript ends up sending requests to our site, which posts unsavory things to our site on that user's behalf. Well, we don't want that. We don't want to allow that. So we're going to have these cross-site request forgery tokens, which all but prevent people from being able to do that. And we're going to learn how to do all that stuff. Is this still burning up? I'm concerned for my laptop. All right, so let's, the first 2 lectures of the homework 2 content is kind of a mellowing down. We're going to talk about some front-end development. They're my only 2 lectures on front-end development. So we'll kind of cool off from homework 1 before we dive into all of that stuff we just talked about in those 5 objectives. So let's talk about front-end development. I'm going to do this under the assumption that most or all of you have seen quite a bit of this content before, so I'll go a pretty quick clip through this lecture. I'm going to try to get the slides from today and Wednesday done today if I can, and then save Wednesday for demos that I think are interesting. We're going to go around the internet and just break some pages and and see how your users are going to break your stuff. That's the intent of showing that. All right, but let's get into it. Yeah, it is low battery already. Man, this is killing me. I don't know what's causing that. So front-end development. We're going to talk about HTML and CSS. HTML, this is the foundation of your web page. This is the foundation of the structure of your web page, more specifically. And then CSS, making it all look pretty. So HTML, hypertext markup language. This is, in essence, content or text that can store links to other text. That's where we get the hypertext from. That's really what it is in essence. Of course, we use it for quite a bit more than that. We developed the whole structure of a page using HTML. But in the beginning, that was the main feature, is that you could link to other text, which we take for granted these days. The idea of a link, that was brand new when HTML first came out. So much so that it got half of the acronym, the hypertext part. HTML is not a programming language. It is a markup language. It's just a way to mark up text. So we're typing text, and we're marking that text using specific tags to give that text some form of structure. So here's some sample HTML. This HTML renders in the browser and looks like this right here. Nothing too fancy, nothing too interesting. This would be saved as a .html file, and then we would serve this up on our server. We'd serve the content of that file, and then this is what would show up in the browser. There are two key parts to HTML, tags or elements, or rather tags that create elements. We're going to mark up our text using open and closing tags, where the open and closing tag for an element have the same name, and the closing tag has this slash at the beginning. Everything in between the two tags is the content of an HTML element. This right here is an HTML element of type H1, which is header 1, and the content of it is the text, my first web page. So elements generated by tags, and these elements can be nested. They can be nested many, many, many layers deep. So for example, all of my tags here, these three elements, are all child elements of the body element, which is a child itself of the HTML element. So we can nest these elements, and that gives us quite a bit of power. It's similar to XML if you've used that before, but it is not strictly XML. It is a bit different than XML, but it has a lot of the same syntax here. There are lots of elements. Not going to go through them. This isn't a 100-level class where I say, now make a table, now make a list. But here are all the ones that I'm using here, or at least most of the ones I'm using here. And you've probably seen all these, so I'm not going to dwell on them. But there are lots of different tag types, which are going to render differently in the browser. The browser is going to look at each tag type and just do something a little different. For example, the title will go inside the head of your HTML, and that's the text that will display in the tab of your browser. So when you open the browser and go to this page, the tab of your browser will say CSE 312-first page. That goes in the head, which is all the content that does not display on the page. This is all meta content about the page, and then everything in the body is what the browser actually renders on the page. Some elements, some tags are self-closing. If you see tags that look like this, where the slash comes after the tag name, this means it's a self-closing tag. If we're posting an image, if we have a line break, if we have a horizontal rule, none of these make sense to have an open and then closing tag because they'd always be right next to each other. There's no content to a line break. So these are what are called self-closing tags. We put the slash at the end. And it's just one tag that is both the open and closing tag. Sometimes you'll see this without the slash. I argue that they're wrong. In HTML5, they are wrong. But sometimes you will see them without the slash. They're still self-closing. The browser will know what to do with that. But you should have that slash there. HTML elements can have attributes. These attributes give extra properties to the elements and allow us to have more flexibility for these. These are always key value pairs separated by an equal sign. So this div has a property named ID with a value mydiv. ID is a very special property in HTML. The IDs have to be unique across a page. So if I have this div with an ID of mydiv, I can't have any other element with an ID of mydiv. These have to be unique, which is very handy when we're trying to find a specific element. If we have one special element on our page, we'll give that a unique ID, and then we'll be able to retrieve that element and work with that element in our JavaScript, which we'll see when we get to JavaScript. Comments, there's no line comments, only block comments in HTML. This is the syntax for them. And we can insert Unicode or UTF-8 into our HTML by escaping the Unicode characters. So there is syntax for this. Start with an ampersand, do the Unicode value, and then a semicolon. And that's going to inject some UTF-8 into your HTML, and it'll render, the browser will render that as the character that you mean with this bytecode. There are some named characters, like a right arrow, that you don't need to memorize the UTF-8 encoding. You can just put the name of that. And one handy one is a non-breaking space, NBSP. If you want an extra space, all extra space is ignored in HTML. So if you put 3 spaces, that's just going to appear as 1 space. All the extra space is completely ignored. So one easy way, if you just want a couple of spaces, put a non-breaking space in there and explicitly say, this is going to be a space, another space, and then another space right here. So we'll get 3 spaces here by adding that non-breaking space in the middle. There are other ways to do this with CSS. If you need a lot of space, don't just cut and paste non-breaking space over and over. You can do vertical or horizontal spacing. But if you just need a couple of spaces, put a non-breaking space in there. That's HTML. That's all I have to say about HTML. The most important things, there are elements. Those elements can have attributes. That's what we need to focus on. That's the structure of HTML. I don't want to go through all the different types of elements. For that, head over to W3 Schools if you haven't already. Check out all the cool elements that you have, lists, tables, and links. I don't even think I showed a link in here. You can study all that stuff there. But the big things we need for this class, elements have attributes. Those attributes, one of those attributes can be ID, and as we'll see in a second, one of those can be classes, which is related to CSS, cascading style sheets. So this is when we want to add some style. We have our HTML, which gives like the skeletal structure of our page, and then the CSS is going to decide how to style that. This is an important concept in web development. We want to keep the structure separate from the style, which is the HTML and CSS, and we're also going to keep that separate from the functionality, which is going to be the JavaScript, which will contain anything dynamic and anything that interacts with the server that's going to be in the JavaScript. If we keep all 3 of these things separate, it's going to help us, kind of force us to organize our code a bit better, not necessarily code, but organize our front-end files a bit better. So we're keeping all these things separate. When we're in HTML, we're only concerned about the structure. When we're in CSS, that's when we're concerned about the style. When we're in JavaScript, that's when we're concerned about the functionality. So changing one or the other shouldn't affect the other 2. You'll never, I don't really have you write much HTML or CSS in this class anymore, but if you are replacing my sample sites with your own sites, which you're encouraged to do, of course, but you're never going to be graded on the quality of that. If it looks like absolute garbage, that's fine. As long as it has the functionality, we're really focused on the back-end functionality in this class. So if your front end, your HTML is just a mess, your CSS has really, just looks horrible, that's perfectly fine. This is an art class. This isn't a UX class. For that, take HCI, Human Computer Interactions, with Alan Hunt, and he'll talk about how to organize and design really nice front ends. That's what that class is all about. So please take that one. I always recommend that class. I recommended this on day 1, but I'll recommend it again. If you take this class and Alan's HCI, you'll be quite a well-rounded full-stack developer by the time you come out. I'll teach you all the back-end functionality. He'll teach you some front-end UI, UX kind of topics, and you'll have a lot of nice a lot of nice experience going out there into the world of web development. There's my note on that. Wow. All right, so here's what some CSS looks like. We're going to specify the scope of the styling, which elements should this apply to, and then the styling itself. So here we're going to set the body, any body elements. The background is going to be aqua. Any paragraph elements are going to have color red and font size 50. So we're going to increase the font size and make it red. For colors, you can either specify the RGB values like I did with paragraphs, or there are certain named colors that you can use the name for. So aqua is a named color, so I use the named color aqua there. Like here, I could also just put, this is just flat red, so I could have just put red here as well. That would have been fine. But once you want those custom colors, you got to start heading over to the RGB values so you can get that exact color that you want. This is one thing, I always get lost in CSS. Picking colors takes forever for me. I don't know. I have no artistic talent, so I just change the RGB values, take a look at how it looks, and then just keep trying. Trying to get those RGB values exactly where I want them. I'll spend hours and then eventually just throw up my hands and be like, you know what, it looks good. But it's one of the CSS pains. They're trying to get something on that perfect pixel, getting things the perfect size, the perfect width, and things like that. I don't know. But anyway, this is how you do it. This would go in a .css file, and then that file would be imported from your HTML. So you would import it. Well, I'm using import, the more programming term, but you would link it. Link that sheet with the name, give it the MIME type, and then that tells the browser that another request needs to be made for this style.css file. Since I used a relative path here, it's going to be requested on the same path as the HTML, or from the same server and port as the HTML was served. You could also do an absolute path, like if you're importing Bootstrap, for example, you would put an absolute path, or download Bootstrap and host it on your own server and put a relative path. Anyway, you need to link your style sheet. That'll send a second request for style.css. If your server's hosting this file, style.css, on another path, then you'll get that request, like you're doing for homework 1, get that request and then serve up that style.css. Yes?
How do websites know how to scale to different devices? Like when you have an website that will have a different HTML and CSS based off of if it's a phone, laptop,
That's all the server has to decide. In the CSS, well, there's a lot of ways to do it. So how does a website know, like if you're on mobile, how to serve up different stuff? It's all in how we build the sites. Sometimes it's a bit more than that. So it can just be the CSS. You can do have the CSS through what's called media tags, read the screen width and height, and then depending on that, style this the sheet differently. So you can have one CSS for all of the page sizes. But sometimes, like, you'll go to a site and it'll explicitly load up the mobile app. I believe that's usually done with a 301, if I'm not mistaken. It'll read, you'll get a page, it'll read your screen size. There'll be some JavaScript that runs right away, read your screen size, and if it's below a certain threshold, you'll get redirected to the mobile site. But it's always through your screen size. If you take your browser and resize it to like the size of a phone, you'll end up at a lot of mobile apps. It doesn't actually say, oh, you're on a phone. It doesn't know that. It just reads your screen size. I mean, it could know that you're on a phone. There are ways to do that as well. But I think most cases it's reading your screen size.
Could you like send that information to like get it through a request?
In JavaScript. So you can go to your JavaScript console and get your screen size.
Okay.
There are a few lines of JavaScript, you can get that. All right, so this is all good. We have every paragraph red and big. But what if we don't want every paragraph to be red and big? This is rarely something that we do, saying like every paragraph should have this styling. We want a little more flexibility in our CSS. So we can do this with what's called classes, CSS classes. in our HTML elements, we're going to add another attribute, which is a class, which tells CSS, hey, this paragraph has a class equal to red, which is just some class I made up. I named it and everything. And then in my CSS, I'm going to say any paragraph, and then using this dot notation, any paragraph with a class of red, style it as red. Any paragraph with a class of green, color it green. So this gives us more flexibility. So we can use classes. It's generally good practice to use classes everywhere. Maybe that's a little strong statement, but maybe that's more my personal opinion. But you should use classes everywhere. If you have CSS applied to any element, I like doing that through a class. I don't like saying anything like all paragraphs should have this. Site-wide, like it's just a little too strong. But if there is certain styling that I want to add, I'm going to add a class, and then any element that I want that styling applied to, I'm going to add that class to it, and then it'll have that styling applied. Sometimes we want even more flexibility than that. If we don't care about the element type, we just want any element of any type with a class of green to have that styling applied to it, we just leave out the element type and just say dot green. Now, anything with a class of green, whether it's a paragraph or a div or the body itself, anything, if it has the class green, it's going to have a text color of green. So here I have a div of class red, but on red, I only said paragraphs are red, so that is not going to render red. But if I just did dot red, then this div content, this text is going to be red in addition to the paragraph. Oops. And finally, I tend to not use this one too much, but depending on how you're building your sites, you might want to use it, is specifying the style of a specific element by ID. So if you have some element with a specific ID, you can style just that unique element with CSS using a hashtag. So hashtag and then that element's ID, and then that element is going to have that styling applied to it. Elements can have multiple classes. Give it a space-separated list, and it'll have every one of those classes. Implication, classes can't have spaces in their names. Space-separated lists, you can have multiple classes. And this is extremely useful, extremely common, to have multiple classes on your elements. Just give it the space-separated list. Now green and wide, both of those are going to be applied to this div. Yes?
Would you be allowed to use Bootstrap for homework?
Yes, I think so. The question is, are you allowed to use Bootstrap for homeworks? As long as it's only affecting the styling, the look and feel, and the UI UX, I'm fine with it. You can use it for your homeworks. Yeah, I had to think about this. I do have a note in the project that you can use it for your project without a report. So I guess that implies that I'm allowing it for the homeworks as well. And there's lots more CSS features. There's all kinds of stuff like the media tags I just mentioned earlier. You know, W3 Schools has this covered. If you don't like W3 Schools, I'm sure you can just search up, help me with CSS, and your favorite search engine will give you all kinds of stuff. There's tons of resources on HTML, CSS, JavaScript. There are tons of people who want to get into web development, and it's usually where they start. So there are lots of tutorials out there, lots of information. That'll probably explain it better than I can, honestly. I just need to focus on the functionality so we have a foundation to build on when we're trying to build our web pages. So with that, let me try to get through these slides as well. Let's talk about JavaScript. JavaScript is a programming language. Hopefully everybody knew that one by now. Maybe some of you haven't, and that's fine. But Java is a programming language, which is going to give us functionality, give us everything, all of our coding knowledge. And this is where we want to spend a lot of our time in this class. If we're in the front end, we're going to be messing with JavaScript for the most part. This is where we actually get to take all of our programming knowledge and apply it to the front end of websites. So HTML and CSS, structure and styling, cool, but how do I get stuff done? That's where JavaScript comes into play. This is where we actually get to really do stuff. It is a programming language, but I'm not going to cover all the syntax. I'm not going to say, here's how you declare a variable in JavaScript. At this point in your careers, you really need to be able to learn the syntax of a new language. If you haven't used JavaScript already, you need to be able to learn the syntax of a new language with no instructions. JavaScript, if you haven't played with it yet, it's going to be one of those cases. How do you declare a function, a loop, etc.? Get in the documents if you haven't used JavaScript already. So without JavaScript, with just HTML and CSS, there's not a whole lot we can do. We can build what I like to call poster sites, where it's effectively drawing a poster, designing a poster, and then pinning it up on the internet for everybody to see. It's great if you want to disseminate information to other people. Like my course website, for example, is what I would call a poster site. I have a bunch of information. I just need to get that information out to all of you. So I put it on my site that's pretty much just HTML and HTML and CSS. With a bunch of links to files, static content that I want to serve. But if a user wants to interact, say we want a chat app, say we want a social media app where people can make posts and everything, HTML and CSS just ain't going to cut it. We're going to need some JavaScript to handle that interaction. And we're going to need a server, of course, like everything that we're talking about on the site. We're going to need a server listening to requests that are sent through the JavaScript to be able to interact with the site. That's what we really need. HTML and CSS are not programming languages. Technically, somebody pointed this out one year, so I have to say it every semester. Technically, they're HTML and CSS combined are Turing complete. You could add a lot of functionality with HTML and CSS. We're not going to. If you build a site like that, you need some help. But you could do it, unless you just do it for a technical challenge. If you're building a live site for users, that's not a site just to show off that you can do it in HTML, CSS. You need some help. JavaScript's sitting right there. It's a full programming language with regular syntax that we understand. Please use that. But technically, HTML and CSS combined are Turing complete, for what it's worth. I don't think you'd be able to send an AJAX request, so you still wouldn't be able to get your functionality, but technically, Turing complete. But JavaScript it's a programming language. It runs code. So think of the immediate security implication here. We have JavaScript on our server. A user visits our site, or let me say it in a different context. We're the user. We're visiting a website. We go to that website. Our browser requests the HTML. HTML says you need a CSS and JavaScript. Request both of those. Download the HTML, CSS, and JavaScript onto our computer, on our computers, on your computer. Every time you visit a website, you're running that JavaScript. You're running computer code that somebody else wrote on your computer. So there should be alarms going off like, man, that sounds like a big security issue. And it is. That's something we need to think about. We're running somebody else's code. If you want to download somebody's Java app and just run it on your computer, I mean, we do sometimes with desktop apps or any apps that aren't web apps. We download it and run that code on our machine, and that is dangerous. We have to make sure we're downloading only code from trusted publishers. If you own a Mac like I do, your Mac constantly yells at you and says, this is unsafe, this is unsafe. I have to say, shut up, Mac, I know what I'm doing. But it is unsafe. You have to make sure you trust that code. So there are, thankfully, a lot of security features built into JavaScript itself. And these are very important. These have to be here. But when we're writing JavaScript for our apps, when we're frustrated that we can't do one of these things, just remember why. We can't do these things because these are extremely dangerous to allow. So 3 major things. We can't read and write files. There's no file I/O in front-end JavaScript. You can use Node for your server, and you have file I/O there. JavaScript that runs in the browser does not have any file I/O. You cannot read files, because of course you can't. Why would you be able to read files from the machine? That would be extremely dangerous. You'd be able to read up all the files from the user's machine, send it to your server, and just completely violate their privacy. We don't allow that. JavaScript won't allow that. You can't do it. You can't read and write files. One of the big mistakes, or not necessarily mistakes, but one of the big hangups that people new to writing front-end JavaScript face is you have your server hosts HTML, CSS, JavaScript. Also hosts some data file with some content that you want to read and serve, but you serve it as a separate file, and then you think in your JavaScript you're going to read that file, the contents of that file, and then use that to load up your web page and serve all the content. It doesn't work like that, because even though that file came from your server, you still can't read it. You still can't read that file. Can't happen. You need some other way to get that content, usually through an API, get the content as a big JSON string through a web request, through an HTTP request, AJAX request specifically, and then handle that content there. You cannot read files. You can't access other tabs or windows. JavaScript can't jump across tabs. Each tab is a separate environment. You can't escape that environment, which thank goodness you can't do that. But if you're ever tempted to want to try to do that, you can't do it. And you can't directly access any content from other sites, not just jumping across tabs. Like you can't write code that says how many tabs are open or what else is this user navigating, but you can't access any of the content. The cookies, local storage specifically, can't read any of that content. You're in a completely separate environment for your app, for your page. Can't read that from other sites, which again, thankfully you can't. There are attacks, I have to put the word directly here, because you can have attacks that attempt to steal that stuff. But hopefully all modern sites are protected, and as we get to cookies and cookies specifically, we're going to talk about how to protect your cookies to make sure nobody can hijack your cookies when we talk about authentication in the fourth homework. And whenever, JavaScript's mature enough at this point that vulnerabilities have been found, they've been patched. JavaScript's got staying power. It's still here. It's still around. It's not something like Flash or Java applets. Those have gone away because they had huge security holes that couldn't be patched, and they just died. JavaScript's here to stay. It looks like. It looks pretty. We're stuck with JavaScript because it is doing its job and it's doing it well. If you remember the days of Flash, if you're old enough like me to remember that, Flash is gone now because it had way too many security holes. It just couldn't. They couldn't keep up. They couldn't patch everything. It was just by design going to have security flaws. All right, so let's look at our first little bit of JavaScript. Not going to do much with JavaScript for now, but let's see a little bit of JavaScript here. We're going to get an element with a specific ID. I'm going to use that myDiv, that div with ID myDiv from the previous slides. We're going to get that element and then modify it a little bit. Not much, but we're just going to do a proof of concept that the JavaScript is running and modifying our page and dynamically changing our content by running code, JavaScript code. We're going to use this inner HTML and set that equal to whatever content we want. So we get a div, we have a reference to the element with ID of myDiv, and then that element, we're accessing its inner HTML field and replacing it, whatever it was, we're going to replace it with this content. We have that div with ID myDiv. It was empty. It's empty right now. There's nothing in it. And this is common. This is something we do often. We'll have some div that's empty, and its sole purpose is to be populated through JavaScript. JavaScript's going to get that div and put something important there. So you'll often see empty divs in HTML files. It's because the JavaScript's going to do something. It's going to look for that div with an ID. Whenever you see an empty div, it'll almost always have an ID. JavaScript's going to look for that ID and populate that div. Then we're going to import our script with a script tag, with a source property, a script element with a source property with the name of the file that should be requested. Again, relative path, so it's going to request from my server. If we put an absolute path there, we can get some JavaScript from some other server, some CDN. If we have like Bootstrap that we're not hosting ourselves, there's CSS and JavaScript involved. You put absolute paths there and get that script. We're going to put this right at the end of the body. Whenever a script is downloaded or whenever the script tag is hit, this one is going to make another request to the server. That request is going to come back, and once that request comes back, that script's going to run. So we want to do anything we can to make sure that this script is going to run after this div loads. There are several ways to do it. The most common these days looks like putting it at the end of the body. You could also put these either in the head or at the end of the body, and then have the body have an onload, and then call your JavaScript when the page loads. That make sure everything loads first. Or put the script at the end. This is already going to load before the request is even sent to get this script. So we're going to have our good order of operations here. You also often see scripts in the head as well. Those are usually libraries where you're not running code as soon as the script downloads. It's code that you're going to use later on in the page, that you're not going to call it right away. And the content's added from JavaScript. So one of the big powerful things that we can do with JavaScript is react to events. JavaScript is event-driven. It's an event-based. I'm losing my wording on that one, but the language is built around the idea of events. Like events occur, and then code happens. Code runs when those events occur. It's very concurrent by nature, listening for events and then reacting to them. So if the user does something, pretty much anything the user does, there are all kinds of events that JavaScript reacts to. Whatever the user's doing, we can react to that event and then call some JavaScript code based on what they're doing. So here's an example. I have some div with some content or no content that's going to be loaded from JavaScript. And I have two events that I'm reacting to, mouse enter and mouse leave. So I'm going to add these properties, on mouse leave and on mouse enter. And the values of those attributes are going to be JavaScript code that's going to run when those events occur. Now to keep things nice and clean, I'm going to just call a method and then have methods in my JavaScript file, so I'm not cluttering up my HTML with a bunch of JavaScript code. So I'm calling my makeBlue function, which I define here, which takes an element. So I'm going to pass a reference to this element. So this div itself, I'm going to pass that to my function. And then I can change the styling. I can do whatever I want, but in this case, I'm changing the styling to change the color when the mouse either enters or exits this div. So say this is my div right here. Whenever that user mouse enters, boom, blue. Leaves, boom, green. So I'm reacting to something the user's doing. There's also on mouse move. One thing that's pretty powerful to do, put an on mouse move on the body of your page. Now whenever that mouse is moving on your page, you can do something with that. You can read the event, get the coordinates of the mouse, and do whatever you want with that information. If you have, if you're building a game where wherever the mouse moves, that's where the player should move. On mouse move on the body, and you can get that information and do whatever you want with it. And here's where we're going to start playing on Wednesday. We can go to the browser console. You can go to the browser console of any page on the internet and type your own JavaScript and run your own JavaScript on that page, which can be pretty fun. I find it fun to go around any page and just run JavaScript and just mess around with that page, mess around with the front end of that page. That code and execute your own code on that on that page. That can get tedious if there's something, if every time you go to a page there's some certain JavaScript you want to run. It'll get tedious to open up the console every time, type it in, and then run it. This is what browser extensions help with, is when you install a browser extension, whenever you go to a page and you can specify which pages the extension is for, it'll run the extension's JavaScript on that page every time that page loads. So if there's something you want to modify, you do to modify a page, write a browser extension, set it to that page, and then have that extension run your JavaScript automatically instead of having to mess around with the console every single time. There are limitations to this. Extensions cannot read any of the variables or classes or objects or anything anything in that page, your extension runs in a separate environment than the JavaScript of that page, but it can mess with the DOM, the document object model, which is where all of the elements are stored. So it can go to any HTML element, find the element, modify it, do whatever you want with those elements to modify that page. And Wednesday we'll do demos. So for example, this is how an ad blocker works. It finds all the elements that look like ads and just deletes them. It's a browser extension that's running custom JavaScript after the page loads. So I'll see everyone Wednesday. I can